Howdy, polar bears and polar cubs. Here we go. We're going to talk about the two different kind of theories slash types of acids and bases. So first we're going to talk about erroneous acids and bases. So these are compounds that increase either the concentration of H plus in the form of an erroneous acid. One that would be an erroneous acid, these would be like HCl, HBr, or HI. And then we have erroneous bases, and these are compounds that would increase the concentration of hydroxide, which are the OHs. So examples of these would be like KOH, NaOH, or LiOH. All of these increase the concentration of either hydrogen or hydroxide by giving them off. The other acid-base theory is we have hydrogen donors and we have hydrogen acceptors. So an example of a Bronsted-Lowry acid, they donate a hydrogen, and then the remaining compound with the +1 that's been donated, it becomes the conjugate base. So for example, for an acid, you have HBr. This is an acid, and with this theory, the base initially would be water. Well, what happens is the water accepts the hydrogen, and now we get what is called a hydronium ion. This is the conjugate acid because it would be able to increase or donate a hydrogen. And then the conjugate base ends up being Br minus because it would be able to accept the hydrogen. That's the acid version of it. The conjugate base, now we are dealing with hydrogen acceptors, and then the one that accepts it becomes the conjugate acid. Just like what we showed up top, except for now we're kind of focusing on a base. So NH3, ammonia is a base. This time water is going to act as the acid. It's still going to, this time water actually donates. So it donates the hydrogen, giving us the ammonium ion. This becomes the conjugate acid because it would be able to give off a hydrogen, whereas OH minus becomes the conjugate base because it would be able to accept a hydrogen. And those are the two ways that we can kind of view acids and bases. But what we really want you guys to kind of dive real deep into is the strength of acids and bases. So when it comes to acids, there are 8 strong acids. And those 8 are, well, let's talk about the 3 binary ones first. Those are HCl, HBr, and HI. Those are the 3 strong acids that are binary, meaning that they have no oxygen. All the rest of them, like HF, okay, or like H3P or H2S, all of those other binary acids are weak. So why are the rest of them classified as weak? It all has to do with the dissociation. The dissociation of them. So what the dissociation kind of happens is it either tells you that, hey, it splits up completely with a single arrow, or it doesn't split up completely with the double arrows, meaning that it kind of hovers around where some of them have given off an H and some of them have not, or all of them have given off. The 5 other strong acids that you would need to know are HClO4, which is perchloric acid, HClO3, chloric acid, H2SO4, sulfuric acid, which happens to be the only diprotic strong acid. So that means that it has 2 hydrogens in order to get rid of when it is dissolved. You have nitric acid. And finally, you have periodic acid, HiO4. When it comes to strong bases, it's quite simple. It is complete group 1, and then these 3 group 2 metals. If you look at your periodic table, what this does is it actually creates a lowercase b. So it is all of group 1 and then 3 in group 2, which if you connect those 2 lines gives you a lowercase b. It makes it very easy for you guys to know and keep that knowledge. All the rest of them after those 8, again, we only have 8 strong ones. All the rest of them are weak, including NH3. So I'm going to go ahead and kind of give you guys a little bit of an insight on what you're going to be doing. You're going to be identifying things as either a strong acid, a strong base, a weak acid, or a weak base. So right now, go ahead and circle the strong bases and box the weak bases. All right, let's go ahead and double check them. So strong bases are circled. That would be potassium, calcium, sodium, barium, rubidium, okay, and cesium, and then all the other ones would be weak. So reasoning here is this is group 1, this is part of the group 2, part of the group 2. This is weak group 1, and group 1. So these 2 are transitional metals. So therefore, they are the weak. All right, that has been a little bit more of an introduction into the strength of acids, strength of bases, as well as Arrhenius acids and bases plus Bronston-Lowry. Good luck on your worksheet.